Okay, let's take a look at problem 3. This is a continuation of Practicum 2 and our checkers game. So, in the game of checkers, it continues. In the first part of the game, all valid moves move a piece forward on a diagonal to an empty space. Starting with your solution in problem 2, extend it. We're going to take where we were and do some more to it so that it takes the same input as problem 2. Hooray, our input is done. But checks each move for validity. Okay, so that's our big thing. Last time we assumed everything was valid, and now we're going to check that each move is valid as it is read. Okay, if an invalid move is encountered, a message is printed out followed by the checkerboard. So we're going to print out, if we're looking for an invalid move, if we find one, we print out the checkerboard, which shows all the preceding valid moves. So we don't make the invalid move, we stop, we show where we ended. If all the moves are valid, then the resulting checkerboard is displayed. Okay, I have a little example that I made here so we can kind of see what a valid move looks like real quick. Same input as problem 2, and then we're told, actually I'll move this down a little bit so it can be near our valid move description. It says a move is valid if there is a checker in the position. So first we care, oops, I'm going to move these over. So first, to be valid, there has to be a checker. So like this is my little starting point. If there's a checker, here's a black checker, here's a white checker, and just so we remember, those are actually held by an asterisk, or in this case, an O for white. So these are black valid moves and white valid moves. Okay, so if we have, first of all, if in the position that we're asked to move from, there is either a white piece or a black piece, here's our white piece or a black piece, then to be valid, it has to be there, and wherever we're supposed to move better be empty. So for instance, if there was a black piece here and we're asked to move our white piece to that new position, that's an invalid move. So first it has to be empty. I'm going to remind myself by that, making that capital. Better be empty space on the board that we want to go. It says, furthermore, it's going to move up a column or up a column or down a column. So from here, it's either going to go one to the left or one to the right. So that's forcing that diagonal. The columns are always going plus or minus 1. And for black checkers, we're going to set the new row better be exactly 1 up in index. So our black piece, a valid move is, we can move here. This is a valid black move, and this is a valid black move. So we can go diagonally. It has to go up to the left or to the right 1 column, and it has to go up 1 row. We'll just remind ourselves that these bottom left corners here, this position right there, that's our 0, 0 is the bottom left. And for all the board positions, this top one is, if it's an n by n board, this is n minus 1, n minus 1. And that's just from the rest of what we've learned so far about this checkers game. Okay, so for the white piece, for the white pieces, if they were starting in this central space, they're still going to be allowed to move left 1 column or right 1 column, but this time R2 is going to move down 1, which means it's we're allowed to move, the white pieces can move down at a diagonal. Okay, so those are the valid positions they can end at, and it's valid if there's no piece there. C2 is equal to C1 plus or minus 1, and R2 is equal to R1 plus 1 if it's black. R2 is equal to R1 minus 1 if it's white. So there's a lot more going on than we've had before, where we checked nothing. So the first thing we need to do is copy over our work. And I'm going to copy the import statement separately. And then I'm going to copy the main method. So this main method is straight out of problem 2. Happy with that. There's the output. Don't want to miss any of it. I'll just go all the way to the bottom. Okay, so now everything should be working as it did before. I don't have anything new, so I wouldn't be checking for valid moves in the previous one. So it would actually run as it is now. It would just give some weird results because there wouldn't be an empty space, so it'd be covering something up, potentially, all sorts of fun. Okay, so now we have to think about what we need to do. So we're going to read in the move, and essentially we're going to do the following. We're going to check if the move is valid. And if it's invalid, we're going to break out of loop and print output. So really we're just going to break out of the loop and the output is going to happen. So what does it mean to be a valid move? So just to remind ourselves, I'm going to turn this into a multi-line comment because there's a lot of things that could make this valid. Check that the move is valid. So to be valid, we have to have the following true. We need board R1 C1 to not be empty. Okay, we need board R2 C2 to be empty. We need C2 to be equal to C1 plus 1 or C1 minus 1. Okay, that's the column is up 1 or down 1. And if I'm going to say if this is black, meaning it's a star, then R2 better be equal to R1. Which direction is it going? I forget. It's going up 1, so plus 1. Plus 1, and if board R1C1 is white, then R2 better be equal to R1 minus 1. Okay, that's everything. Okay, so these are all the things that make it a valid move. So if we encounter anything else, if it's invalid, we want to break out of the loop and print the output. Not can put in parentheses, and then we will print the output because the output happens down here. So all we really need to do is break out of the loop if we encounter anything that's invalid. So if this is what makes it valid, we're looking for the opposite of those. And if we encounter the opposite of those, we can break. So in this case, the opposite of that position being not empty is that it is empty. So if it's equal to dot, then we are going to break out of this loop. If, on the other hand, we have the next one says if board R2 C2 is empty, so this time it's invalid. If it's not empty, then we're going to break. And we're going to break out of the loop and go. Okay. If, on the other hand, that just means it's invalid. So there's a lot of ways. You could just break at this point, but you could also have created, and this is probably what I would have gone for, valid move. We'll assume it's valid. And the other thing we could have done is just change it to invalid at this point. So we could say valid move equals false. And we could do that every time we encounter something that makes it an invalid move. How this plays out is up to you. And honestly, as long as we get the job done on a practicum, it doesn't matter. Okay, so the next thing is if C2, C2 better be equal to C1 plus 1, or C2 should be equal to C1 minus 1. So in this case, the opposite of it being either C1 plus 1 or C1 minus 1, you could break that into kind of 3 conditions, right? Either C2 is less than C1 minus 1, or C2 is equal to C1, or if C2 is greater than C1 plus 1, so if it's in any of those ranges, it's not okay. Then the move is invalid. So valid move is set to false, and we break out of the loop. And so finally, the other thing that would make it invalid is if for some reason, I'm going to start with this piece because I think that makes the most sense as our starting point. The case of what if the position that we started from is black, which is our asterisk piece. So if it's a black piece and R2 is not equal to R1 plus 1, then it's an invalid move. And if I copy this, the other thing that would make it an invalid move is if that position were white and R2 was not equal to R1 minus 1. Okay, so all those things make it invalid, but that just checks for it being invalid. And in fact, so this is actually going to come out here. Sorry. So now this is just everything that checks if it's a valid move. Okay, so here we're checking if it's a valid move, and then if it's invalid, we're going to break out of the loop and print. And I think I have something a little bit backwards, because the other piece that we needed is if it's valid, then we're going to move. And that's the part I definitely missed because I left this up here. And the reality is one of the changes I have to make is I have to first check if it's a valid move, and then if it's valid, I can move it. So if, what's it called? Valid move. Then I can do all of the stuff from above. So that's that make the move scenario, right? Otherwise, if it's invalid, and so that's our else, and it's okay that there's that gap there. Otherwise, we're gonna break out of the loop. But I think we actually are asked to first output something. I forget exactly what, but we're asked to output invalid move. So the first thing we'll do, I'll change what it says. If invalid, output, and break out of loop. Okay, so that's the part I forgot about. There we go. Okay, so we'll try it and see what happens. Let me copy the input. And it probably will have some error. No doubt I'm missing a semicolon. Oh, no missing semicolons. That's a win. Oh, there we go. Okay, so that's it. It seems to be working. We can play with other examples, but I feel pretty good about what that added. So that's where we'll end it. There it is. We check for the move validity and we break out. So at this point, we have a solution that works, but what I notice is that I've got a Boolean value for valid move, and then I have a bunch of decisions that basically determine whether or not this valid move is true or false. And the reality is, this is the perfect candidate to move into a method. And so let's do that, because we're working on methods. And so let's do that because it makes sense. And so we'll go ahead and create a method, and it's good practice. And so we've got a method that is going to return a Boolean, and it's is valid move. Makes sense as a name. So we know that it's either going to return, when I see is in my name, I know it's going to return true or false. And it's going to be based on all sorts of information. So what do we need to pass it for it to work? Well, all we really need in this case is we need to pass it the board. So in this case, we're passing the board, we're passing R1, we're passing R2, and obviously then I'm using, C1, I'm gonna put them in order just so it makes sense to me, R2 and C2. All of those things are, are part of this decision-making process, right? If I look at what I did up here, and I'm just going to copy it all. I'm going to copy all of this, cut it right out of there, and I'm going to put this in here. So obviously there's going to be some issues, but because I don't have valid move, this is now out of valid move is within scope in the main method, but it's not in scope in this method. And I chose, like, I wouldn't have to name these board R1, C1, R2, C2. But the reason I did that was because I knew I was copying that piece in there. It's a different R1 than above, but I knew that when I copied this in, and now I didn't have to fix anything. And so what I can do is here keep the same logic, and essentially this doesn't shorten anything, but there's a reason that I might want to do this. Move. What this does is it just cleans up everything else we've done above. So I keep all the same logic right in here, and now the method is determining whether or not this is a valid move. So within our code, what that means is I could have called that method and just said valid move in our main method is as simple as is valid move, where I pass it the board. Oops, did I misname that? Maybe I did. R1, C1, R2, C2, in that order. And something I did there is, here we go. Now it's fine. Now it sees it. And so I should have caught on when I typed is that I had done something wrong. So I had to let it know it's not attached to anything. It's static. So there's my static method. So this didn't change anything about how this ran, but it is an example of the fact that, you know, when I look through this code, it just moves some of the logic out into a reasonable place. It keeps it all tidy and together. Is valid move is one big decision, and there's a lot to it. So keeping that separate just means when I look through the code here, you know, it's pretty easy to see what happens. And so I could take a lot of this and move it out and put that as a description for that method, which, you know, one should do. If you're going to create this, we should put in a description of what this does. And that's it. That's the end of Practice Practicum 2.